Welcome to Study Loop.
Okay, so for this question, so first we need to calculate the constant tau, which is equal to RC. It's going to be equal to, we're plugging the number, which is going to be equal to about 11.1 seconds. Okay, so we can use this tau to calculate the other values. So for question A, we need to calculate the charge on the capacitor. So Q equal to the capacitance times the EMF times 1 minus 1 e to the negative t over tau, right? Where tau is the RC. So we know the capacitance is 12.4 mu farad, and EMF is 60. Okay, and we already know tau. So we can easily calculate that when t equal to 0, Q equal to 0. T equal to 5 seconds. Q equal to 2.7 times 10 to the negative 4 coulomb. Equal to 10 is going to be 4.42 times 10 to the negative 4 coulomb. And T equal to 12. So Q equal to 6.21 times 10 to the negative 4 coulomb. And finally, T equal to 100 seconds. The Q is going to be equal to 7.44 times 10 to the negative 4. So for question B, similarly, the current is equal to the EMF over R times e to the negative t over tau, right? So we know the EMF 60. We know R is 0.895 times 10 to the 6 ohms, right? So we plug in the number again. We can have when t equal to 0, have I equal to the maximum value, which is 6.70 times 10 to the negative 5 ampere. Equal to 5, it's going to be 4.27 times 10 to the negative 5 ampere. Equal to 10, we have 2.72 times 10 to the negative 5. Equal to 20, we have 1.11 times 10 to the negative 5. And 10 equal to 100, we're going to have 8.20 times 10 to the negative 9, which is way much smaller than the others. So with the help of all these values, we can plot the figure for question C. So for the charge, it's going to increase through time, so it's going to be something like this. And for the current, it's going to decrease through time, and it's going to be something like this. Okay, so this is time, this is current, this is time, this is charge. And you can plot it precisely with the help of all these values you calculate about.